Hey everybody. Today we are going to talk about what you should have seen in the lab, mostly Ohm's law. So hopefully from the lab you were able to get a nice linear graph of V versus I, and you got a nice diagonal graph. And if you weren't thinking too much about it, first thing you look at is your slope, which is voltage over the current, which hopefully you noticed the slope value was the same as your resistor value, considering it's an online experiment, there's no uncertainty. So you would have seen that the slope of this graph is the resistance. And rearranging this, we get that voltage is equal to current times resistance. That's Ohm's law. It is kind of nice in the sense that it's really only three variables. It makes sense. If you keep the resistance constant, so if we keep the resistance constant here, you could see that if V goes up, I goes up, which kind of makes sense because if there's more pumping power, you should get more flow. And if we keep the voltage constant and say we increase the resistance, so we have more clog, you would get less flow. So the equation makes sense both mathematically and conceptually to most people. Now we do have to define one other thing, and that's current, which is charge per unit time, or coulomb per second. That's what it's measured in. A coulomb per second is equal to an amp. So those are two new basic equations, and we have to derive a few more, but that is the definition of current and Ohm's law. So let's get to deriving, shall we? Now, in the past, we've done that power is work divided by time, and the units for this would be, that came out weird that time, a joules per second. From our previous topic on electric fields, we know that voltage is equal to work over charge, which is measured in joules per coulomb. Now, just above in orange here, we have that current is charge, total charge per unit time, or coulomb per second. So I was wondering if there's any way we could take these two values and put them together in such a way that we get units of joules per second. I wouldn't want you to think too much about this, but if you want, pause the video, give it a thought. Welcome back if you left. But it should be pretty obvious. If we simply take the product of the two, I times V, that would be a joule per coulomb times a coulomb per second. And would you look at that? What did I do wrong? Oh yeah, sorry. I spaced out there for a second. You get joules per second, which is the unit of power. Okay. Now, really quickly, there are two other equations for power. And how we do that, normally we'd spend a little more time in class and let you figure it out for yourself. But what we're going to end up doing is we're going to take Ohm's law, and I like that pink there. Let's try that out. We're going to be taking Ohm's law and substituting it into our power equation. For example, if I take power equals current times V, well, V is simply IR. We get that power is equal to the current squared times resistance. Now, in the future, I would suggest using that for anything in series. I'm going to say usually series, but not always. You'll see as we get farther into the topic as to why. Now, I could also rearrange V equals IR for I and get V over R and throw that into the power, and I get power equals V over R, sorry, it was supposed to be a capital R over here, times V, or power equals V squared over R. I tend to use this usually with parallel. usually. And you'll see why as we get farther into the topic. So basically the point of this quick video was to make sure that you saw the direct relationship between current and voltage. We derived Ohm's law. We have a new equation for current, which is charge per unit time. And we have three new equations for power. People always ask, when do I use which? Well, what do you know and which one should you use? It's really not that difficult. Use whichever one you can. The homework that's associated with this was mentioned in the lesson or the email that you got sent, and that's about it. So, as always, if you have any questions, email me or visit me during my office hours. Looking forward to seeing you. Hope all is well.